I want to talk about the 68, 95, 99.7 rule, and we're going to assume that we have a mean of 120 and a standard deviation. So this rule is used for the normal distribution, and it has to deal with the percentages of area under the curve, under the normal curve, a certain number of standard deviations away from the middle of the distribution, which we're going to show as the mean. So the mean of 120, we put 120 here in the middle, and then we add one standard deviation to 120, or remember the standard deviation in this case is equal to 5. So we're going to add 5 to 120, and that'll give us 125. So we would say that's one standard deviation above the mean. And then this 2 sigma, again that symbol, population standard deviation, is showing that we're 2 standard deviations above the mean. So we take 2 times 5, get 10, add it to the 120 and get 130. And then we can take 3 of those 5s, or 15, and add it to the middle. Here we have 135. And you'll notice that the curve doesn't go really much beyond that. It actually does theoretically go on for infinity, but realistically there's not much area out there beyond 3 standard deviations to the right, or 3 standard deviations to the left. So we do the same thing, working our way to the left of the mean. We'll subtract 5 from the 120 to get the 115. That puts us 1 standard deviation below the mean. And then we'll double that and take 10 from that. So that will give us 110, which is 2 standard deviations below the mean. And subtract 15 from 120, which puts us at 3 standard deviation. So if we wanted to calculate area beyond values, either to the left of some values, to the right of certain values, or in between values, in this particular distribution with those parameters, we can use this empirical rule to do that. For example, we could ask what percent of scores are to the left of 115 or less than 115. So we would add up the 13.6, the 2.1, and the 0.1. So it'll give us roughly about 15.8%. So 15.8% of all the scores in this distribution would be less than 115. If we wanted to find how many scores were between 115 and 120, we could look here and see that 34.1% of them would be in this range. If we wanted to find how many scores were above 130, we would take this 2.1 and add it to the 0.1, and we would have 2.2% of all scores in this distribution would be greater than 130. If we look between 2 scores, for example 110 and 130, how many scores would fall in this range, which would be plus or minus 2 standard deviations? We would have to add all these numbers up, and we would get roughly about 95%. So you can figure out, just again, these are just the particular values or distances away from the middle, measured in terms of standard deviation. It gives us a rough idea of the spread of a distribution and how those scores are distributed throughout a particular distribution.